The next topic in gravitation is expression for time period of a satellite. So we shall derive the expression for time period of a satellite. We all know that time period is equal to distance by speed. We all know that time period is equal to distance by speed. Now, distance traveled by satellite is equal to 2 pi into r plus h. So, distance travelled by satellite is equal to 2 pi into r plus h. So, this is the given value. You should know this. So, distance travelled by satellite is equal to 2 pi into r plus h. Now, time period that is equal to t is equal to, so the distance is 2 pi into r plus h divided by the speed is v naught, which that is the orbital speed of Earth satellite, that is v naught. So here v naught, we have the value of v naught that is equal to square root of gr. So v naught is equal to square root of gr. So for h is equal to 0, the t is equal to t naught. For h is equal to 0, the t is equal to t naught. So let us replace the t naught in the place of t here, and let us put 0 on the place of h here. So the expression becomes t naught is equal to 2 pi into r plus h is 0 divided by v naught is square root of gr. So this is what we got. So now let us simplify this equation now. So t naught is equal to 2 pi. So r could be written in the form of r square root of r into square root of r, and square root of gr can be written in the form of square root of g into square root of r. So this we have learned in our school in our 9th standard and 10th standard classes. So the r could be written in the form of square root of r and square root of r, and square root of gr can be split into two terms, square root of g into square root of r. So square root of r, square root of r will get cancelled. So now t naught is equal to 2 pi square root of r divided by square root of g. So this is what we got. So after this, t naught is equal to 2 pi. So this numerator and denominator, they both have square root here. So they can be written in a single term. So the 2 pi into square root of r by g. So this is the time period of a satellite. So t naught is equal to 2 pi into square root of r by g. So this is very simple. So first we need to know the time period. The time period is given by distance by speed. Next, distance travelled by satellite is equal to 2 pi into r plus h. So let us substitute all those things. Time period t is equal to 2 pi r plus h divided by speed is orbital speed, that is v naught. We have already derived the expression for v naught, that is square root of gr. For h is equal to 0, t is equal to t naught. So let us substitute all those values here. T naught is equal to 2 pi r into square root of gr, since h becomes 0. So we have got this value. So here I have split this r into square root of r into square root of r, and square root of gr into square root of g into square root of r. So this we have learned in our mathematics classes. So I have used basic level mathematics upon this equation. So after this, I have got this equation and I have this numerator and denominator together, which has both square roots. I have put them together. So T naught is equal to 2 pi into square root of R by G. So this is the expression for time period of Earth satellite. Note, so we know that T is equal to 2 pi into R plus H divided by V naught. Okay, so we also know the value of V naught. V naught is equal to square root of Gm divided by R plus H. So this equation we have an orbital speed of Earth satellite. So we shall make use of this equation. So we shall substitute this V naught upon this equation. Now this equation becomes T is equal to 2 pi into R plus H divided by, so here what it becomes, square root of Gm. So here square root of Gm, here we have square root of R plus H upon the denominator. So the denominator of the denominator will come to the numerator. So it becomes square root of R plus H. So this is how it will be. So now what we do is we shall simplify this equation. T is equal to 2 pi. So here we have R plus H. Here we have square root of R plus H. Okay. So here R plus H times 1. So it has the power 1. But this thing, it has the power 1 by 2. So 2 pi into R plus H 1 plus 1 by 2. So we have the power 1 here. So if we convert the square root in terms of power, so we get 1 by 2. So I have taken both terms together. So it becomes 1 plus 1 by 2 divided by square root of Gm. So here T is equal to 2 pi square root of R plus H. So let us take LCM. 2 ones are 2. 2 plus 1 is 3. So it is 3 by 2 divided by square root of Gm. So now I'll square on both sides here. So now what our equation becomes, T square is equal to 4 pi square divided by square root of Gm. So whole square, the square root will get cancelled. We will get only Gm into R plus H whole to the power of 3 by 2 into 2. So 2 will get cancelled. We will get only square root to the power of 3. Here T square is equal to 4 pi square divided by Gm into R plus H whole cube. So this is the expression. So I'll put K upon this term. So I'll take K is equal to 4 pi square divided by Gm. So I'll replace the whole term with K here. So T square is equal to K into R plus H whole cube. So I have got this equation here. So we have got this equation, T square is equal to K into R plus H whole cube. So what does this equation tell you about? So this equation speaks about the time period T. So it has some constant K. It speaks about the radius R and H resembles the height here. So totally what is this equation trying to tell you about? So this speaks about Kepler's third law of planetary motion. What does the Kepler's third law state about? So it states that the square of the time period of the revolution of the planet around the sun is equal to the cube of the length of the semi-major axis of the ellipse. So this speaks about the mathematical form of Kepler's third law. So Kepler took around 18 years to find all the three laws of planetary motion. So first two laws, they were too easy to find out. So he found them very easily. But this third law took many years for him. So because it needed to have a mathematical proof to find out the exact value of that. So for that reason itself, he discovered this equation. So E square is equal to K into R plus H whole cube. So this is the Kepler's third law of planetary motion. The next topic is expression for energy of orbiting satellite. So the energy of orbiting satellite. So now a satellite which is revolving around the sun, around the earth, the satellite which is revolving around the earth will possess kinetic energy as well as potential energy. The kinetic energy is because of due to its orbital motion, and the potential energy it will possess just because of position with respect to earth. So the satellite will possess kinetic energy because of orbital motion, and potential energy with respect of potential energy because of position with respect to earth. So the total energy is equal to kinetic energy plus potential energy. So the total energy, that is E, is equal to kinetic energy is half m v naught square plus potential energy is minus g m divided by r plus h. So this is what we got in potential energy of potential energy. This equation we had. So here I'll take the value of V naught is equal to, you all know the value of V naught, that is G square root of Gm divided by R plus H. I'll substitute this V naught upon this V naught here. So I substitute the value of V naught in this equation. So it becomes V is equal to 1 by 2 m. So here we have V naught is equal to square root of Gm by R plus H. So here we have V naught square. So square root of Gm divided by R plus H whole square. So the square root and square will get cancelled. So the Gm divided by R plus H will remain minus G m divided by R plus H. So this is what we got. I'll rearrange this equation. So E is equal to 1 by 2 G m divided by R plus H minus G m divided by R plus H. So here we have the common term Gmm divided by R plus H on here as well as here. I take them as a common here. So E will be equal to G m divided by R plus H. Here 1 by 2 will remain minus here 1 will remain. So this is what I got. So here I'll simplify this, further simplify this. So E is equal to Gm divided by R plus H. 1 by 2 minus half will be equal to minus half. So E will be equal to Gm divided by R plus H whole to the power of into 1 by 2 minus 1 by 2 Gmm divided by R plus H into minus 1 by 2 will remain here. So minus 1 by 2 minus 1 is minus 1 by 2, that I have written here. So I'll multiply this minus 1 by 2 onto this expression. So I'll get the value E is equal to minus Gm divided by 2 into R plus H. So this is the expression. E is equal to minus Gmm by 2 2 into r plus h. So this is the expression for energy of orbiting satellite. Energy of orbiting satellite. So I'll explain this again. A satellite which is revolving around the Earth will possess a kinetic energy as well as potential energy. So kinetic energy is because it is because of orbital motion of the satellite, and potential energy is because of the position with respect to Earth. So the total energy will be equal to kinetic energy plus potential energy. The kinetic energy, you all know that half m v square. We have v naught here, so half v m v naught square plus potential energy is equal to minus gmm by r plus h. So we have this expression in this chapter. We have derived this expression in this chapter. So v naught, we all know that v naught is equal to square root of gm divided by r plus h. I'll substitute this v naught upon this equation. So I'll get this thing. So I'll rearrange them and I'll get this expression. So I'll take all the common terms. So common terms have taken out. So I'll get 1 by 2 minus half will remain. So 1 by 2 minus 1 is minus half. So I'll multiply them. So minus gmm divided by 2 into r plus h. So this is the expression for energy of orbiting satellite. Here negative symbol resembles what? What does it indicate? So here negative symbol indicates that the satellite is bound to the Earth. The satellite is bound to the Earth. It travels around the Earth itself. So that is what it says. So what happens if this value becomes positive? So if it becomes positive, what happens is the satellite will definitely escape from the gravitational pull of the Earth, and it can go up to infinity also. So we don't know that exactly how much distance it can travel. So there are satellites for research purpose that has been sent far away from our Earth. So it is traveling. It is still traveling. Okay, the satellite which has been sent around 30 years before itself, it is still traveling in a solar system. So because of that research purpose, they have sent a satellite there. So it will travel. So if this value becomes positive, then the satellite will escape from the gravitational pull of the Earth. If this value is negative, it will be bound to the Earth. It will revolve always around the Earth itself. Note, P naught is equal to 2 pi into square root of r by g. So we know this value. So the radius of Earth is equal to 6,400 kilometer. So I'll convert this into meter. So the radius will be 6.4 into 10 to the power of 6 meter. So the value of g is equal to 9.8 meter per second square. So this is the value of g. I'll substitute all the values onto this T naught. So T naught is equal to 2 into the value of pi is 3.14. So it's not enough. I'll write below. T naught will be equal to 2 into 3.14 square root of the value of r is 6.4 into 10 to the power of 6 divided by the value of j is 9.8 meter per second square. So if we simplify this, if we solve this, I'll get a value of 85. So around this I'll get. So 85, I'll get a value around 85. So 85 approximately, that's not exactly, it is approximately equal to 85 minutes. So what is this? T naught is approximately equal to 85 minutes. So 85 minutes is the minimum amount of time. So it's not a minimum amount of time, it is the time required for the satellite to revolve around the Earth. So this is the time period of revolution of the satellite around the Earth. So that is exactly equal to 85 minutes. So it has to be around this value itself. If you take any satellite, it cannot exceed this value. So it should be around 85 minutes itself. So this is the time period of the revolution of the satellite around the Earth. So next topic is weightlessness. When a body is in free fall, its weight is 0. So when a body is in free fall, so you might have experienced this while traveling in the lift, while traveling downwards in the lift, as well as in the giant wheel. So in the amusement parks, you people might have seen giant wheels which will be kept there. So while coming down from the giant wheel, you will experience that you will experience like as if you are flying in the sky. So you will feel that as if you have no weight at all. So that thing itself is called as weightlessness. So when the object is in free fall, even in the lift or as well as the giant wheel, so your body will be in the form of free fall. So it will be like free falling itself. So at that time, its weight is 0. So the weight will be 0. That is called as weightlessness. So in this state, the reaction on the body is absent. So the reaction on the body will be absent. So in the satellite, everything inside it is in a state of free fall. So people will say that in the satellite there will be no gravity at all. So there the satellite will experience this weightlessness. So the everything, the computer, compass, everything, all the scientific equipments that will be present in the satellite will experience this weightlessness. So they'll all be in a state of free fall. So this is all about weightlessness. So this is the conclusion of the gravitation. So here, this is the last class of gravitation. In the next class, I'll be doing certain problems regarding this gravitation. Thank you.